Welcome to Session 22, Mental Math and Exact Arithmetic Sprint. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to recognize exact arithmetic shortcuts, to write short auditable work, and to recover quickly from a stalled item. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Mental mathematics is controlled structure, not rushed guessing. Use this visual structure. Classify is greater than exact steps, is greater than estimate, is greater than confirm. Read every symbol and label before calculating. The first goal is to recognize exact arithmetic shortcuts. Connected to the second goal, write short auditable work. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Classify the structure before computing. State the target and preserve its units or conditions. Step 2. Keep fractions, radicals, and powers exact. Use a separate line so signs, factors, and labels remain visible. Step 3. Write one valid operation per line. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Estimate and move when the path is unclear. Verification is part of the solution because it tests the answer from another direction. Signal 1 is friendly root or factor. Respond by remembering. Simplify mentally. Name the response before calculating. Signal 2 is a reciprocal pattern. In that case, rewrite before arithmetic. The form tells you which tool fits. Signal 3 is work stalls. Remember, preserve the last correct line and return. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is a challenge. Evaluate less than or equal to t 23 to the power minus 2. Restate what is requested before touching the choices. The first move is classify the structure before computing. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Invert the fraction and square. 3 over 2 squared equals 9 over 4. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Write one valid operation per line. The explanation supports one option without relying on its position. The mathematical conclusion is 94. State it with any required units, interval notation, or restrictions. The final answer is 94. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction, reverse the operation, or estimate between nearby benchmark values. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. During a no-minus calculator sprint, what should happen after a method stalls? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. Focused hint. A preserved valid step supports an efficient return without sacrificing later items. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is mark the last valid line and move on temporarily. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to recognize exact arithmetic shortcuts. Combine that with the discipline to write short auditable work. Finish by remembering to recover quickly from a stalled item. A result becomes dependable only when the method and verification are both clear. Reflection. Which written line would expose a sign or reciprocal mistake fastest? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 10 exact arithmetic minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.